All right, we're on lesson 4, the last lesson for this week, which is 8-12. So make sure you're in your SAB. And basically we're going to do a lesson where we kind of look at length, area, and volume all together, because there's different times where you're supposed to use different ones. So let's start there first. We've got some vocab terms over here, which are going to be kind of helpful. So I'm going to start over here to the top, at the top. So it says length tells how wide, tall, or long something is. Finding length requires one measurement. Length is a one-dimensional and is measured in linear units. For example, how tall you are is considered your length, or like I can't think of another example. How long a football field is, that is, although I guess technically you could measure area for a football field. That was a bad example. How far you walk somewhere could be measured in length. So length is just one-dimensional. It's one line, which is why we call it a linear unit. Area tells how much surface a figure covers. So finding the area of a rectangle requires two linear measurements, and area is two-dimensional and is measured in square units. So that's the better example of a football field. You could figure out the area of a football field, or the area of the carpet in your house, or a rug, or the area of a poster on your wall, because those are all two-dimensional shapes. Volume tells how much space an object occupies. Finding the volume of a rectangular prism requires three linear measurements. Volume is three-dimensional and is measured in cubic units. So you could find the volume of a box, or the volume of your box of cereal, or like the volume of, so volume could be like anything that's box-shaped, anything that can hold something else on the inside of it. So over here, this is doing a good example of showing you what they're talking about. Length is just one-dimensional, it's one line. Area is at least two lines, but you can see that they create this square shape, or possibly even a rectangle. And then a volume is a three-dimensional shape as well. Okay, so that's got the three parts to it. So let's look down here at this side. It says to answer these questions, tell if you need to measure for length, for area, or volume, and then write the number of measurements you'd need to make. So this will be good practice. So it says how much water is in a swimming pool. Well, that's something that's holding something inside of it. So that's going to be volume. So we'll put a volume right there. And then with volume, you're going to need to make three measurements. You need to know the length of the pool, the width of the pool, and the height of the pool. So then I already gave you this example for how tall you are. That's going to be a length, because that's only one measurement. Okay. Then it says how much carpet is needed for a floor. We did talk about that one as well. That's area, and you need to have two length measurements, length and width. Number 4 says how far it is from a doorknob to the floor. So think about that. They just want to know the height from your doorknob to the floor. So that's just going to be a length measurement. And you should only have to measure one thing. Number 5 says how much sand is in a sandbox. Well, that's holding all that sand, so that's going to be volume, and you'll need three measurements there. How much wallpaper is needed for a wall? That's just a flat surface, but you need to have the length and the width, which is two measurements. How long a string is? That's just going to be one measurement, so that will be length. And the answer is 1. And then it says how much space is there inside a refrigerator. Again, that's going to be a three-dimensional shape. So we would need volume, which takes three different measurements. I got excited about the refrigerator one because my refrigerator just got hooked up, which is very exciting. Okay, so on to the next couple of problems that we're going to do. These are just real-world problems that are going to have different things that you're going to solve. You're either going to solve for probably the area or the volume. So let's see what we got going on here. So number 9 says, Soledad has a storage box. That already makes me think volume. It says the box is 6.5 inches long, which they showed here. It's 4 3/4 inches wide, and then it's 7 inches tall. She wants to run a border around the top of the box. How much border does she need? Okay, we got to be careful here. I don't think she actually wants there to be anything other than just material running across the top. So that actually makes me think that this problem would be perimeter, because I just want to know how much fabric or whatever she needs to run a border across the top of this. So this 7 inches tall doesn't actually even mean anything. What I'm going to need to do instead is I'm going to need to add 6.5 inches and another 6.5 inches, because there's 2 sides. So that would be 6.5 plus 6.5. And then I'd also need 4 3/4 plus the opposite side of 4 3/4. Okay, 4 3/4 plus 4 3/4. So this is an addition problem. I'm going to do something kind of easier first. You're going to have to bear with me here because there's a lot to add here. I'm going to take my whole numbers first. 6 plus 6 plus 4 plus 4. Well, 6 plus 6 is 12, and 4 plus 4 is 8. So I know that 12 plus 8 is 20. So far my whole numbers add up to be 20. And now I get to just take my other increments. Well, what's a half plus a half? That's just a whole. So now I'm going to add 1. So the good news is really after I look at this problem, even though it looked kind of hard at first, all I really have to do is add 3/4 and 3/4. Well, 3/4 and 3/4 ends up being 6/4, which I would not leave that way. 4 goes into 6 one time. That leaves me with 2/4. And I know that this isn't even simplified yet, so this needs to be 1 1/2. So that's the last thing that I'm going to add to this problem. Whew, that's a lot. So basically now I'm going to add 20 plus 1 plus 1, which is 22, and then that half. So my final answer to number 9, 22.5 inches. Remember, in perimeter, there's nothing square about it. It's just simply 22.5 inches. Make sure you wrote that one down. That's a hard one. Okay, so for number 10, it says the refrigerator is 5 2/3 feet tall, 2 2/7 feet wide, 2 1/4 feet deep. How much space does the refrigerator take up on the floor? Okay, think about that, guys. That's not volume. That's asking you how much area it takes on the floor. So I don't need to know how tall it is. I'm going to X that one out. But what I do need to know is how wide and how deep it is. That's going to be your length and your width. So that means I'm going to take 2 2/7, oops, and I'm going to multiply that by 2 1/4. Well, the good news is I don't have to change my denominator, but I do have to change these to improper fractions. So 7 times 2 is 14. 14 plus 2 is 16. So this is going to be 16/7 times, and then this is going to be 4 times 2 is 8. 8 times 1 is 9, and this would be 9/4. So I'm going to multiply 16/7 times 9/4, but hopefully you pumped the brakes because I see 16 and 4 here. So this 16 and 4, I know I can reduce those. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So now this problem is going to be way easier because I already divided before I started. So now I get to just do 4 times 9 is 36. And 7 times 1 is 7. Now I just need to simplify. 7 goes into 36 5 times, which is 35. And that'll leave me with 1 little 7th left over. So after all of that, the area that my refrigerator will take up is 5 1/7. This is feet. And remember, it's area, so that means that they are squared. So 5 1/7 feet squared. Okay, I'm going to erase a couple of things here, so pause the video if you haven't written this all down yet, because otherwise I'm going to erase, so I have more room here. Oops, I don't want to actually do all that. Okay, there we go. Get rid of those. All right. I actually am going to get rid of that. You get the picture. Okay, so for number 11, that's the next thing I need to solve. This one was 22.5 inches, by the way. So number 11 would be the next one that I'm going to solve, but what I did is I kind of looked to see how much time I have left, and 11 and 12, when I solved these on my own earlier, they each took me probably 5 or so minutes to solve and explain. So in the interest of time, if you want a challenge, you are welcome to try these ones out. I will tell you they're very difficult. Number 11 was 12 storage cubes, and then number 12 is the other one that we're going to skip, but you could try it as a challenge if you want. That one was $195.75, but 13 and 14 I'm going to solve with you. Those are good ones that we can practice, and they go fast. So Parker builds a planter in the shape of a rectangular prism that is 6 feet wide, 3 feet deep, 2 feet tall. How much soil will he need to fill it? So that's very similar to that flower bed one we saw earlier. So if it's 6 feet wide, 3 feet deep, and 2 feet tall, oh gosh, why did I try to draw that? Okay, sure. Anyway, all you need to do there is multiply 6 by 3 and by 2. 6 times 3 is 18, and 18 times 2 is 36 cubic feet. Oh my gosh. 36 cubic feet is what I was actually trying to write. Cubic feet. All right. And then finally for number 14, definitely another challenge one, but a little easier to explain in the time that I have. It says a box is a rectangular prism with a square base. So they're trying to show you that you have a square base. Something to notice about a square base, though, is that they are going to have the same dimensions, right? Because that's what makes something a square. It says the volume of this shape, again, I don't know why I'm trying to draw these. That's real bad. Whatever. They're telling you that the entire volume equals 972 cubic centimeters, and that the area of your square base that they've already solved for you is, oh gosh, I made it worse. The area of your square base is 81. So they're telling you that they multiplied these out, and that already equaled 81 square centimeters. So we want to know the height of the box. So basically all that means is I have to take 972, which is my volume, and divide it by the two sides that I've already multiplied, which is 81. So 81 will easily go into 97 one time. So I can then subtract that 81. 7 minus 1 is 6. 9 minus 8 is 1. And then I bring down the 2. And that's pretty easy. 81 will go into 162 two times, which is 162 again. So that tells me that my answer then is 12 centimeters, since I'm only finding the length of one side. There's no cubed or squared or anything about that final dimension. So, for your last bit of practice today, if you want to spend your time solving 11 and 12 as a challenge, I invite you to do so, but I also would tell you that's not the way that I'd prefer you spend your time. Instead, I'd actually rather you tried out some homework and remembering pages, or obviously iExcel is always an option. So you guys can try those out in order to get some practice for today. Good luck!